So 4.8 will be all about writing quadratic functions. Now, throughout this entire unit, we were sort of handed or given these functions and equations and then asked to do stuff with them. Here's a quadratic equation. Can you factor and solve them? Here's a quadratic equation. Can you do the quadratic formula? Here's a function. Can you graph it and find the vertex, maximum, and so on and so forth? So in order to go backwards, we sort of have to know what the equations of quadratic functions look like. And we've already discussed this, I think, in the beginning of the unit when we did graphing. So let's recap or recall the three forms of quadratics functions. We have standard form. That's everything is loose and separate and all separated. That looks something like f of x equals ax squared plus bx plus c. So you have an x squared term, an x term, and a constant term. We have vertex form, which looks like a times x minus h quantity squared plus k. And the reason why we call it vertex form is because the vertex is always located at h comma k. And then lastly, we have factored form or intercept form, right, which looks something like f of x equals a x minus some number p times x minus some number q. And the idea is that you should be able to solve the x-intercepts really easily because the x-intercept will be located at whatever the first parentheses is equals to 0, and whatever the second parentheses is equal to 0, and then you go ahead and solve it. Well, not surprisingly, what form we use will sort of depend on what information we're given. Let's take a look at an example here. Suppose I ask you to write a function of a quadratic that has a vertex of -2 comma -3 and goes through the point 0 comma 5. So, I mean, this is not meant to be a trick question. We have three forms of a quadratic. We have standard form, vertex form, intercept form, or factored form. This example, they give us a random point and a vertex. So which form, standard form, vertex form, intercept form, should we use if they give us a vertex? I'm laying it down pretty thick here. Again, it's not meant to be a trick question. Hey, they give us a vertex. Why don't we just use vertex form? That's the big secret. That's the big trick. So it's not a big trick at all. You just have to understand what type of information you're given and then choose the right form. So I know that my final equation should look something like I'm just rewriting it so I don't have to scroll back up. F of x equals a times x minus h squared plus k. Here's the idea. Any question that asks you to come up with a model or equation, every single bit should be filled with a number except your output and your input. So those guys I highlighted should stay as variables. That means my final answer, the a should be a number, the h should be a number, and then the k should be a number, and leaving the f of x and x as variables. So how do we do this? Well, what you do is you just read the information they give you and figure out where it belongs. So let's go ahead and read this. Write a function of a quadratic that has a vertex of, hey, they gave me a vertex. I need to know that the vertex will always be h and k. And it goes through this point 0, 5 here. Now, relative to the special parts of a quadratic, remember, quadratic is just a parabola. The special pieces are what? The vertex, the x-intercepts, and maybe the axis of symmetry. This point here, 0, -5, is just a random point on the parabola. He really isn't anything special in terms of the format here. So what information, what values are you given if you just have if you just have a single point? I hope everyone understands that every single point is just a regular x and a y. All right. Oh, by the way, y is the same thing as f of x. So there you go. That's all you got to do. Just plug in the information you're given. So I'm going to use this format, but I'm going to change the variables I'm given into numbers. So f of x, we said that was 5 equals, look at the two pieces of information. Did they give you an a value? The answer is no, so you just keep it as a variable. X, they give us an x value, that's 0. Minus, do they give you an h value? Yes, they do. Now this minus here was part of the formula, so I got to put it there, but my h is actually a -2. That's why I always use parentheses when I substitute, so I can see those double negatives. Squared plus my k value is -3. Notice what it gives us. It gives us an equation that we can solve for a. So that's it. Just do math and solve for the variable. So I'm going to solve for a here. So you have 5 equals a. Inside here is 0 minus a -2 is just a regular 2. Plus a -3 is a -3. 5 equals 2 squared is 4. So add the 3 over and then divide up the 4. You get a equals 2. Now remember, that's not our final answer. A is just a number. We just solved for a. The question says write a function. So I need to go ahead and write this as my final answer. But again, anytime they ask you to write a function or write an equation, every piece should be a number except for f of x and x. So let's go ahead and plug everything in, write our final answer. So what is our function? What is our answer? It's f of x equals the a value that we found, parentheses x minus h, which was -2, squared, plus k, which was -3. And of course, we can go ahead and take care of the double negatives. 2 times x plus 2 squared minus 3. This is a function that has this vertex and is guaranteed to go through that point. So it really doesn't get any more complicated than that. Hey, if I ask you to write an equation and I give you a vertex and a point, use vertex form, plug it in, solve for a, and then write your final function. Well, what if I give you this example here? Write a quadratic function whose x-intercepts are x equals -3 and x equals 2, that also goes through the point -2, -4. Well, gee, let's survey and scan the information we're given. Write a quadratic function whose x-intercepts are, so they give us x-intercepts. Gee, they give us x-intercepts. We have 3 forms of an equation: standard form, vertex form, factored or intercept form. They give us x-intercepts: standard form, vertex form, intercept form. I wonder what form we're going to use. Again, I'm being very thick and obvious about this. I hope it's no big surprise that, hey, if they give us x-intercepts, we should probably use intercept form. So I'm going to go ahead and write that down. So intercept form is ax minus p, x minus q. So then let's just jot down and figure out what information we're given. So the x-intercepts they give you will be your p and q values. And again, this point here is just a generic random point. So that's your x comma y. But we just have to remember y is the same thing as f of x. So plug everything in. F of x, according to our labeling. So look at these pieces here. F of x is -4 equals a is just a letter. They didn't give it to us. X is -2 minus your p value is -3. X is -2 minus your q value is 2. And then you just do math. So -4 equals a, -2 minus a -3 is a +1, -2 minus 2 is a -4. So you get -4 equals -4a. Divide both sides by -4. you get a equals 1. So we got lucky here. We got a equals 1, but it doesn't have to be. It could be a number bigger than 1. Heck, it could be a fraction. It really doesn't matter. But, excuse me, once you solve for a, you're basically done. Remember, your final answer should be your original model with everything plugged in except f of x and x's stay as variables. So my final answer would be f of x equals the a value that we found, which was 1, x minus my p value was negative 3, times x minus my q value was 2. And of course, when you multiply by 1, you really don't need to write it. So let's write our cleaned up answer. So it would be x plus 3, x minus 2. This equation, this function, would satisfy the above conditions here. So that's basically it. If they give you information about vertex, guess what? Use vertex form. If they give you information about intercepts, use intercept form. Now they can also ask you to put it in standard form, but remember, standard form is just everything multiplied all out. So just do your normal thing, vertex form, intercept form, but then go ahead and take the extra step of foiling it out, doing repeated distribution to multiply it out. For example here, suppose I asked you to write a quadratic equation, or quadratic function, and it's going to explicitly state in standard form, right? It has to be in standard form. And instead of writing it out, let's say they give you a graph for the following graph. So obviously on your practice and on your quizzes and tests, they'll be computer generated, but we'll have to hand draw the graph here, right? And let's do a quick sketch. So suppose they just did a quick sketch here, and you can read that your vertex is at 1, negative 2, and let's say that this point here is at 3, 2. I don't know. Well, it doesn't matter if I write it out or give you a graph. You just have to look. Gee, what information is given? Well, I sort of said it out loud when I did this quick sketch. They gave us a vertex. I wonder what form we're going to start with. And you're absolutely correct. If they give us a vertex, we use vertex form. So vertex form, just copying it down again, x minus h squared plus k. Remember, your vertex is your h and k, and your random point is x and f of x. So we plug everything in to solve for a, right? So we have f of x is 2, x is a 3, h is a 1, k is a negative 2, right? I did that fairly quickly, but all I'm doing is just taking the h, the k, the x, the f of x, and I'm just plugging it into the spots in the structure. So hopefully we can then just do algebra or arithmetic and solve for a. So that's 2 squared minus 2. I'm going to add 2 to both sides. So that's a 4 equals 4a. A equals 1. So in this case, a was 1 again. So it's sort of nice when it's a easy whole number. But remember, it doesn't always have to be. So let's write our full function. F of x equals, now since a was 1, I'm not going to bother writing them down. X minus h was 1, and k was a negative 2. Okay. So this technically is our answer in vertex form. But notice the instructions doesn't say vertex form. The instruction says standard form. So all you got to do now is go ahead and just expand this guy out. So you have to remember that squaring something means multiply by itself. So that's x minus 1 times x minus 1. And then don't forget this minus 2 here. And then you just go ahead and FOIL, repeat, distribute the first two parentheses. So x times x is x squared. X times minus 1 is minus x. Minus 1 times x is a minus x. Minus 1 times minus 1 is a positive 1. And don't forget your minus 2 here. Any part of your problem that you don't do, just keep bringing them down. Oops, that should be a 2. And then combine like terms. So that's x squared minus 2x. And these guys combine to a minus 1. There we go. There we have it. This is the equation in standard form for this graph. So that's basically it. If I ever ask you to write an equation given the graph, first figure out what parts can you easily read. Can I easily read the vertex? Use vertex form. Can I easily read the x-intercepts? Use intercept form. And once you have that down cold, if it says standard form, all you have to do is multiply it all out. There you go. That is 4.8. So give it a shot. Give it a practice.